I'm Brian Carlson from GPI. I'm out of our Buffalo office. I am not Josh Blue. I could beat him in arm wrestling, but he could outrun me. So, I'm going to talk about the historic stone arch bridge rehab in South Main Street in Jamestown, New York. It's an 1872 arch bridge. I'll go over the background and history, our design approach to the rehab, and then I'll finish with a lot of construction photos. This project was completed in 2018. Jamestown, New York is in the southern tier of New York State. They're in the orange circle. Wilmington's down here in the lower right. So that's where we are relative to the location. The bridge is located in a river valley coming off of Chautauqua Lake into the Chautauqua River. Excuse me. And it's located right there at the outlet of the lake. Let's see here. I'll start with a little history. The bridge that we worked on was actually the third bridge at this location. Previously, bridges were built here. The photo is of one from 1866. This area is known as Brooklyn Square. It was developed in Jamestown, heavy industrial, with the water power from the river for grist mills, sawmills, other manufacturing. The bridge shown in this picture met its demise in 1871, and its failure was documented in the Jamestown Journal, and I wanted to share one part of that news article. Today, about 1 p.m., as Mr. Newell Wilson of Buckland's Corners was driving a drove of cattle across the bridge over the outlet at the foot of Main Street, the bridge broke and 36 cattle went through the opening. It goes on, and I'll get to the end. Now let the village fathers put something up permanent in the place of the defunct institution that will not shake down at the blowing of a ram's horn or the trampling of Newell Wilson's steers. A single stone arch would be good economy, and now, if ever, is time to make the outlet bridge of sufficient elevation that the foot of Main Street can be raised so that the wagon track may cross the railroad track at least 10 or 12 feet above it. We don't write newspaper articles like this anymore, so I felt that was kind of interesting. So, my notes down. So in 1872, the new bridge was constructed, and there was an article on it at the time. And what I want to point out about that bridge is the entire bridge was constructed for a total cost of $12,000, and $9,750 of that it was in the stone masonry. $12,000 in 1872 was about $233,000 in today's money. Obviously, bridges cost more, so direct inflation quote doesn't kind of work there. This area of Jamestown continued to grow up and be developed, and by the early 20th century, this postcard view shows that you don't even see the bridge anymore or the river. They had built up buildings and industry all over it. There's the railroad bridge in the middle of that postcard. Is this the laser? Yeah. Railroad bridge is right there. The highway bridge, our bridge, is right in here under the river, which you can't even see anymore because it's under all the buildings. And in 1974, urban renewal came to Jamestown, and they tore down a lot of these old dilapidated buildings that weren't used, built some parks in the area, and they, quote unquote, found this bridge. And in 1974, they decided they were going to replace it, but they decided to keep it. And they added, since they tore down the buildings, they had to add some new parapet walls, which is the lighter stone, and they had to build some wing walls since there were no buildings there anymore. But the darker stone there and the darker stone is the original 1872 bridge. In 2000, there was another small rehab project on New York State DOT. They went through and for scour protection, they put in some sheet pile and stone fill under the arch. They relocated some utilities that were on it. They moved the sanitary off the arch and put it under the creek. They repointed the stone masonry and parapets, and I forgot to mention, in 1974, they shotcrete the arch. In 2000, they removed all the shotcrete that hadn't already fallen off and repointed the arch. Unfortunately, shortly thereafter, in 2002, they noticed some settlement issues with the bridge. You can see there's a sag in the upstream parapet wall. So this was 2 years after the 2000 inspection. We're looking north because you can see the railroad bridge there again, right behind it. 2014, the structure was inspected, and there were several red flags and 2 yellow flags. And you can see in the photo there, there's icicles from the arch, which is never a good thing, showing all the water infiltration, and it had blown out some stones of the actual arch barrel under the sidewalk. At this point, the county engaged GPI to help monitor the bridge, and we helped scope out a project, and then our rehab project started in 2015. Examination showed that the pier had started to rotate also, but this is just showing some of the, you could see up to the sidewalk, you could see under drain, loss of fill, so freeze-thaw action of the water infiltrating the fill caused the arch stones to eventually pop out. And then, I guess there's, say, the pier, upstream end of the west pier, upstream west end of the pier settled several inches over the upstream 12 to 14 feet of the pier, up to 4 inches. You can see the orange line is horizontal, and you can see the pier stones below that are starting to rotate, and it developed some other cracks because of the rotation in the arch. And so we knew we had, and the downstream end also exhibited a slight rotation, but not to the extent of the upstream end. So we knew we had to work on rehabilitating or restoring the pier as well as the superstructure of the arch for the rehab project. So I'll get into the design approach now. Why rehab? The bridge was 150 years old. It was masonry and it was historic. We knew going in that full replacement was never going to get past New York State Office of Parks and Historic Preservation. We knew it just wasn't going to get funded or allowed. In fact, the 2000 rehab started as a design approach, but a 1996 resource evaluation identified the bridge as eligible for inclusion in or listed on the National Register, so their project became a rehab in 2000. And so what we did is, to rehabilitate the bridge, we had to repair the arches, we had to repair the spandrel wall, and we replaced the parapets since we were taking them down to get to the spandrel wall. The abutments, from everything we could find, were in good condition, and work had, because work had been done in the 70s to enhance the conditions at the abutments. The center pier, as I showed, was in poor condition on the ends, and it needed foundation improvements. As to be expected, we had no plans for this bridge at all. Nothing to go by. We had to base a lot of our design assumptions on historic masonry and other structures from that time frame of what we thought it would look like. And of course, when we got to construction, I'll show that we weren't always correct. So for the pier rehab, these were relatively low arches, so there was no access to drill or drive deep foundations near the pier for support. We considered drilling new piles through the center pier, but we rejected that because the narrowness of the pier. The pier was only about 3 foot wide, and we didn't want to drive any wider, a pipe or pile through there. We were afraid what could happen, cause blowouts or other issues. So what we ended up doing is we ended up putting micro piles at either end of the pier to support and stabilize the ends of the pier. But the micro piles were designed to carry the load of the end 13, 14 feet of the pier. Then we put a concrete collar around the pier for additional bearing area to confine the pier and original piles, and to contain some grouting, which we did. I'll explain the grouting in a few slides. The dowel design was designed to transfer load from the last 6.5 feet to the end of the piles and transfer load from the pier to the reinforced concrete skirt. So kind of covered this, micro piles at the pier ends, permanent pipes and pier. We did put grouting beneath, we did grout through the pier, but we did gravity grouting on a smaller diameter pipes, so we weren't too worried about that. We didn't want to pressure grout. We didn't want to blow anything out. We just wanted to fill any voids that existed below the pier. This is a plan sheet showing kind of the final details of what the center pier design looked like. This is a detail of the end. We had the upstream and downstream sheet piling. We used that for part of like a cofferdam, and we attached a whaler, so when we excavated and put in the micro piles, we would have had some bracing there. And this is a section just showing the micro piles at the typical end of the pier. We had 3 at each end, 2 battered and 1 vertical, and they were all in the cap. And we had a detail for the pier cross section showing the collar going around the pier, and we had a smaller diameter vertical pipe for grouting. For the rest of the rehab, or the arch, we repaired the arch, put the stones back in. We totally unloaded the existing arch, took all the fill out so we could fix the arch stones where there were blowouts and cracks. We put a reinforced concrete saddle over the arch just to, not so much to take the load, but just to tie everything together, keep everything together. We put in a lightweight concrete fill, and we replaced the relieving slab over the top of the arch, just to distribute the loads through the fill. Now I'll get into some of the construction photos and talk about, what we found in this site and how everything went. So this was a 2-season project. The first year, we kept the bridge open for traffic for the most part, and they worked on the pier and the pier collar, and then the second year closed the bridge and did all the arch work. So they're installing the micro piles at the upstream end. When we were working on this, we were diverting water through one barrel and working on the other barrel as appropriate. So the micro piles went in, and then we did the micro pile testing. Our results were good. The field tests compared very well to what we designed specs and designed what we thought we'd get. So there wasn't any real modifications needed to the micro piles as they were installed. This is a shot showing the upstream end of the pier. You can see the micro piles. The contractor started excavating. You can see the sheet pile that was put in 2000 right here. You can see some timbers below the pier. The pier was stone resting on hemlock and oak timbers, and those timbers were all that timber was on wood timber piles. This is a gap in the sheeting. So when they were driving the sheeting in 2000, they were too close to the pier, and they hit or disturbed, moved the timber cribbing and the timber piling that was there. They couldn't drive the sheeting here. It was hitting something. And so that's why shortly after, 2 years later, they started to see a rotation in that pier or settlement in the spandrel wall. It unfortunately disturbed the underlying conditions. This is that whaler and support going in. You can see they started putting some of the dowels into the pier. Micro piles are in. They're getting ready to continue the work on the collar. This is as we were excavating underneath. There was existing timber there. It was one of the forming timbers. It wasn't structural. It's kind of there holding the other timbers in place, kind of. So we found a few of these as we went. They were in good condition. The ground line really was probably about the middle or the upper portion of this core, this stone, I should say, right about here. So all this below here was under the stream bed. You can see they had a mini excavator, like a bobcat in there in the photo. Now put putting the concrete collar in, reinforcing's ready to go. They're starting to pour the concrete in the other photo. Finished up the one end, and we're working down the pier collar along the side of the pier there, ready to form that up and pour, and then there's a pour. So that collar went around both sides of the pier, upstream and downstream ends, and then we went, I showed this earlier, we went to grouting. After the collar was in, we put some grout pipes in through the center of the pier and then did some gravity grouting just to fill any voids that may have existed from over the years. So they did this from the original, roadway surface. They saw cut through the slab, the relieving slab that was there, put in the grout pipes on the left-hand photo, and they're doing some gravity grouting on the right-hand photo. These grout pipes then would get cut. When we excavated the arch, these grout pipes got cut off at a lower elevation. They weren't always sticking up through there. You'll see them in later photos cut off. So this was the first year. Obviously, there was no traffic when we were doing this, but for a lot of this, there was traffic. As expected, the upstream end took the most grout because that had the most issues when we were done with the grouting. Then, like I said, we got into the rest of the rehab, replacing the stones in the arch, the reinforced arch saddle, lightweight fill, relieving slab, new parapet walls, etc. So the first thing the contractor had to do was put in their shoring. This was designed, we gave them a concept, but it was designed by the contractor, stamped by their PE. They put these on Jersey barriers so they could, they work on both barrels at the same time. Obviously, had to shore both barrels at the same time. Water flowed around them. Wasn't really an issue. Everything worked out. You can see it's a pretty tight location with the worker on the right there. It's not a lot of headroom here, but they managed to make it work. Then they excavated through the fill. We excavated down to the arch, and the good news is all the stones were still in the stream bed, so they just recovered them from the stream bed and rebuilt the arch. Had masons out there. The masons love this job because they didn't get to do this too often. They had a lot of fun working on this job. Being in an urban area, we did have some utilities. We were able to remove the water line for work, but the telephone and the electric company, we weren't able to remove their ducts entirely. So the one on the left, this is a telephone duct bank supported by a strong back from the contractor, and the one on the right here is an electrical duct bank also supported by a strong back. They were in the fill. You can see in this photo the arch has been it's been pretty much unloaded. The sheet pile here, there was a manhole on the far side vault, and it wasn't as deep as the bottom wasn't as deep as we thought it was, so the contractor had to throw some sheeting in there just to keep it from being undermined when they laid back around it. The other two tall piles there and there, that was something the contractor put in for their use. I honestly don't remember why those were there, but we're looking north, there's the railroad bridge again. Here we're forming the concrete saddle. The arch is totally unloaded. The grout pipes are cut down here, so they're forming the saddle, placing the rebar, pouring the concrete, started at the pier and worked toward the abutments. Just another photo of them placing concrete on the saddle. Everything was, once we got to this point, was going pretty quickly once they got it unloaded. You can see the parapet wall on the lower left has been taken down here at this point. We were getting ready to rebuild those. Next photo, the saddle's in, the parapet wall's down. And the reason we had to take the parapet wall down was the earth pressure that caused the stones to blow also caused a bow in the spandrel wall, so we had to take them down by deconstructing them and then reconstructing them in conjunction with the parapet wall. We did put a waterproofing membrane over the saddle just to help out keeping water away from the masonry for the future. Also, with the lightweight concrete fill that we put in, It was selected because it was relatively impervious and limited the lateral forces on the spandrel walls. We just wanted to keep as much water out of the arch to avoid the situation that got us into this rehab. This is the lightweight fill going in. Unfortunately, working in an urban area, even though we had vehicle and pedestrian detours, the pedestrians, especially at night, didn't always want to take the extra quarter-mile walk to get around the bridge. So they would try to walk across the bridge, and our EIC got more than one call at like 2 in the morning from the cops in Jamestown pulling people out of the fill. In this one, you can see back here, this lightweight fill, they had sunk in up to about their waist and had to get pulled up by the fire department, I think. So that was one of the problems working in an urban area. Is it was that, and another one, we had them, a couple meth heads burn down a porta potty. That was fun. So it was, there's challenges to working in an urban area. This is the relieving slab going back in. This is one thing we changed. The previous relieving slab only went curb to curb. We wanted to go parapet to parapet, but with some of the utilities there, we weren't able to during design, but as is kind of typical with these projects, the contractor was able to negotiate with the utility owners, and they moved stuff for them that they were unwilling to move for us. So we were able to go parapet to parapet with the relieving slab. And the parapet work here, the contractor extended the shoring so they could work off it, and then they put some other platforms up there. So working on the parapet, some of the details in '74 when they rebuilt the parapet, it was a concrete faced, or it was a concrete core with stone facade. We pulled the stone off carefully, put in a new vertical concrete core, and then replaced the stone on there, and we changed the capping. The original detail was a metal railing like the original, but then the owner decided they just wanted a concrete capping on there, so we changed that during construction. So this is the parapet wall being constructed looking north. You can see the relieving slab is curing, and then this is kind of finishing up. They're putting the stone back on the parapet wall. We had some decorative lighting. The lower photo, that's a box for the pull box for the lighting. Forming the sidewalk, placing the sidewalk. And then once everything up top was done and the arch was, final loaded, they did some final tuck pointing of both barrels working in there. They had obviously shorings removed at this point, and they're just working off of platforms. This is a completed photo. This was just taken with a drone earlier this month. So the road has seen a little, it's got some crack sealing on it and everything. But the arch is still in very good condition. There's a park, there's a river walk on the left side, up on both sides of the bridge. There's a pocket park on the right side, upper right side, or I guess it's like over here, this park, there's river walk. So it's working out pretty good. This was shortly after being completed looking south. Everybody was real happy with it. The town, the village, the city, the county. Once the project was done, everybody was really excited. This is downstream fascia. You can see the coloration. The existing, it's a little rougher stone, but this is the original arch, and we rebuilt around it. The total cost of the project came in at $3.5 million, $120,000 less than the bid price, but it's for a project or a bridge that's only 60 feet. That's when you add the two arches together. It's a large sum of money, but for this bridge, it was totally worth it, in my opinion. I'm not sure this is the same photo. I'm not sure why that's in there twice all of a sudden. Nobody else has done PDHs. I won't go through these. I'm going to just skip past these. since nobody else has done those. And just, again, acknowledging the Chautauqua County Department of Public Facilities, who we were their client, the Fenton History Center, who gave us a lot of the background on the bridge, and the contractors there, Union, Haywood Baker, and the Jamestown Bureau of Public Utilities. So that's all I have, and I'll take some questions if there are any. Oh, come on, Dick.
Did